The physics of this one isn't different than the physics of the last one. We've got something going in a horizontal circle. We're going to assume that the string is horizontal. What I wanted to introduce this time is a notation you'll see once in a while, where instead of talking about how fast it's going, they talk about the frequency of the rotation. And later when we get to satellites, instead of frequency, satellites are often quantified by the time period of their rotation. To deal with this, what we have to remember, and you saw this in the lab, when something's going in a circle, it's going at a constant speed, so we can apply v equals d over t. The distance it goes is a circumference every time period. So we can say that speed is 2 pi r over time period. We'll use that when we do satellite questions later. For this particular question, whenever you have a time period on the denominator, that's equivalent to frequency on the numerator. Then it's really just an F net equals ma question again. I forgot to draw my free body diagram. Oops, that's terrible. Let's try that again, a little bit slower. We've got an object going in a horizontal circle. Tension's what's pulling it towards the middle. That's Ft. Gravity, it's not really showing the 3D very well. Gravity straight down. It says that the circle's horizontal. So in this question, the only force pulling it towards the center is the force of tension. So Ft becomes our F net, and the A becomes V squared over R. In this one, what we're going to switch around is, we're going to apply V equals 2 pi RF. So F tension is mass 2 pi RF all squared all over R. Expanding that out, we get, I'm going to switch the order a little bit. The 2 squared makes 4. Pi squared is pi squared. We've got an m I can't deal with. I've got an r squared, but then the r on the denominator make just a regular r, and then f squared. In this one, we now know everything but the tension. 4 pi squared, the mass that was made up was 40 grams. Oops, so 40 grams, sorry, not thinking. 40 grams we need to put in kilograms, so 0.04. The radius was 1.2, and the frequency was 2. If you crank all that out, oops, forgot 2 squared. I think I did that right on the calculator when I did it. I got 7.6 newtons. So horizontal circle again, the only force pulling it towards the center is tension. Just this time to make you think, instead of giving you the speed, I gave you a frequency, and you can work through